I'll try to reshare it, see what happens. It says it's sharing on my end. Somebody could let me know if they're seeing it, the whole slide, nothing getting cut off.
Okay, we've got it. We see the whole slide. You're good.
Okay. Well, shall we go ahead and get started?
I think we should. Go ahead, Randy.
Okay. Awesome. You could be a moderator. That'd be great. So, good afternoon and welcome everybody. I'd like to introduce myself. My name is Randy Pagels. I am an Azure Cloud technical specialist, and I focus mostly on app dev. I am based out of the greater Detroit area, Michigan, and I cover what we call our Great Lakes region. So that's Michigan, Ohio, Kentucky, and Pennsylvania, New York State as well. So what I like to do is just take you through a stroll. So sit back and enjoy this. The idea is just to stroll through what Azure DevOps is and how we use it to build software at Microsoft, mostly Windows. I thought it was an interesting presentation, so I'd like to share that with you and some of the insights that we have as well. So thank you everyone for joining. To level set, Azure DevOps, again, Azure DevOps is formerly VSTS, so we did rename it. It is the next evolution of our VSTS product, which also came from earlier versions called Team Foundation Server. But this is the tool that we've been using within Microsoft to fulfill our DevOps transformation, is the Azure DevOps tool. It is free. It's good for everybody up to 5 users, free for 5 users, so without getting into licensing. But there's a URL in the slide deck. I'd be happy to share that out later. What is DevOps? Just to level set this before we jump into how we're using it. Again, the quote here, the idea is that DevOps is the union of people, process, and products, and enable continuous delivery of value. And I want to point out the word value. Value is what it's all about. It's delivering bug fixes, delivering new features. We call that value. If you're, and of course, delivering this in a continuous manner. You see the chart on the right-hand side. There's no beginning, there's no end. This is all about continuous delivery. So using CI, CD, and planning work, developing, building, testing, deploying work, operating whatever the work is, the program processes as well, monitoring from these and providing feedback into the process. Again, this is a continuous cycle. So again, rebranding, renaming what DevOps is. You see a slide now with 5 icons. I'll let this go ahead and update, make sure that's updated okay. The way Azure DevOps is built is a suite of tools. Any one of these can be turned on or off if you, for instance, aren't using it. I'll give an example of that just in a little bit here. Agile boards is all about planning your backlogs, breaking your work down into stories, into sprints, and assigning tasks and work. So there's a lot of GUI, UI, bells and whistles that go with this to go ahead and manage your teams, manage your work. Azure Repos is all about putting your source code into creating Git repos. We also support Team Foundation version control, so TFVC. And also, of course, you can pull your code from wherever it happens to live, if it's GitHub or Bitbucket or wherever it is. And then there's Azure Pipelines, which is what I like to think is the heart and soul of Azure DevOps. It's all about building and testing and deploying code. And to do it in a very continuous, repeatable manner to create this pipeline and have it execute the same way every single time. Lower left corner is about Azure Test Plans. It's all about test case management. So this is really about managing your manual tests, test steps, test cases, filing bugs, screenshots, recordings, and things like that. But it is really all about manual test cases. And then there's Azure Artifacts. Azure Artifacts is the ability to create your packages like a NuGet feed or NPM feeds. That's what that's about. Again, any one of these can be used. If they are used all together, of course, you get the biggest bang for the buck. You get that end-to-end traceability that goes throughout the entire system. You'll see the URL again, lower right-hand corner. So let's go ahead and look at what we're doing. This is I like to say the fun part of this, the Azure DevOps piece. So before DevOps, so we didn't always use DevOps at Microsoft. About 10 years ago, so there's things are a little bit different, right? So on the Visual Studio team, for instance, they were siloed, used Team Foundation Server to manage all their work items, source control, and to do their builds. So not everybody in the company used TFS. In fact, the Windows team, for instance, they used a homegrown tool product called Product Studio to manage work, and another one called Source Depot to manage source code. So this isn't very efficient when different teams are building different tools. Right? We should be pulling a single best of breed tool, because if someone wants to switch teams, for instance, maybe go work on the Windows team, they didn't have to go and learn a whole new set of tools. So A few years ago, we set out to build what we call a one engineering system. So one ES. Microsoft loves we love our acronym, so one ES, but it is one engineering system. And the goal is to do just that, build a best-of-breed technology tooling. And this came down from the top. Our CEO, Satya, said basically we had to modernize our systems and start using these systems internally. This is how it started. Now, you might have heard this term before, but we do eat our own dog food, as the saying goes, and we build them and use these systems. And ultimately, at the end, we deliver these systems to our customers. Of course, we start internally. So over the last few years, really, we've been moving everybody in Microsoft dev teams to Azure DevOps. As you can see by some of these staggering numbers here, Microsoft is by far the largest customer of Azure DevOps. Show you a few numbers here. If you look at some of these pull requests, 300,000 pull requests, 4 million builds a month, 2 million commits, and to Git is pretty amazing as well. 78,000 deployments per day. So we're measuring these things now, and again, it's a little staggering when you look at these things. So let's talk about, back to what I mentioned earlier in DevOps. DevOps is all about delivering value. So for instance, the Azure networking team, right? They're putting together fiber, they're making the connectivity faster between data centers, they're building new racks of compute nodes, etc. But they aren't really building software. So what they do, they just use the agile board piece of the Azure DevOps and turn off the rest, clean up the UI a little bit, streamline things. And another example, Visual Studio Code. So this team is building software, but they're open source. So they use GitHub for the source code repo, and they use the Azure DevOps pipelines for their builds and releases. And of course, there's the Bing team, right? They're using everything. They use the entire suite, from planning their sprints to source code management, builds, and releases. So we have everything there. So interestingly enough, looking at this one team stands out bigger than most, right? By the sheer volume and scale of the work they do. That's the Windows team. The ambition that they have building across so many different devices, it's actually amazing. So let's look at that. Let's talk more about that. The Windows. So Windows ships on a variety of form factors, as we probably all know and love, but Windows is one of those set of software experiences that powers everything from the HoloLens to the Xboxes, servers, and desktops, etc. No surprise there. When you think about how the code exists, right, it exists in a couple of different ways. The one core code is a common and runs across all the different form factors. Each form factor has a specific code edition that basically runs and that customized experience for whatever device it's running on, right? And of course, to make those devices work, we need a layer of drivers that are part of the stack that I'm showing you right now. And then, of course, on top of both of those, you have the apps and services that give you those curated experiences that you know and love. So across all these devices, across all the different code, it creates a mammoth set of repositories. The Windows code base is 500 gigabytes of source code across 6,000 repos. It's just really mammoth. I can't use that word enough. So just imagine the collection of people it takes to pull together Windows is about 22,000 people on the team, which is larger than most tech companies. So this just shows you an example of that. I'm hoping the slides are keeping up okay. So looking at some of the daily activity here, the release activity of the people is a pretty challenge at scale, right? Some of these numbers you're looking at here, 11,000 plus software engineers on the team, right? We're doing almost 500,000 pull requests, a lot of 4 million builds across these as well, 500,000 pull requests, right? That's 500,000 people asking for code reviews on different services and code all the time. And we run about 3 billion test cases per release. So the numbers are just staggering, right? And of course, the frequency is another challenge, right? It's something that, just imagine across all those different form factors, with all that different code across all the different people, the daily activity you have with that, the frequency is every frequency you could possibly imagine, from daily, weekly, monthly, semi-annually, etc. So it's pretty amazing. So the Windows team, they were pretty delighted when they got invited to the One ES system, the One Engineering system at Microsoft, which of course now is Azure DevOps. So some of the challenges I'd like to walk through on some of that, we'll start with basically agile planning and work items. How do we plan the work? How do we do the work management piece of this at scale across 7,000 developers, 11,000 engineers, 22,000 people? How do we do that? As you can imagine, right, having so many people jammed into one DevOps account generates a lot of work items. You look at the slide here, 11 million work items is an actually amazing number of work items, 350 million revisions, and over 2 million, almost over 2.5 million queries. It's a lot of information, right? So when you think about work management and how we align our teams, the bigger challenge is how do we get 11,000 engineers to work independently, but yet together? I found that interesting as well. So this is a balancing act, as you know, across the Windows team. So if you're shipping every day, they have to operate nimbly with agility. Right? We also have the need to be predictive. So we need to be aligned to a common set of dates. So the foundational way we do this and structure all of our tools and processes against is our taxonomy. So we have a taxonomy that is common language we speak across any group that participates in Windows. The top level, at the top three pieces of this pyramid, those are the customer promises we make to basically, to the public. At the bottom level, you see where deliverable and the tasks are, that's the teams that are actually working on the tasks and individual work items, which gives them a ton of autonomy to figure out the best way for them to work in this model. But as long as they're sticking with the nomenclature, that's the important piece here. And to put this in perspective with the numbers, this slide showing you that at the very top we have over 40 different stories, right, that we want to tell to the marketplace, to customers on what this release is going to have. You see 3,000 scenarios, more than 38,000 deliverables, and 143,000 tasks. So it gets there's a lot there as well. So as you can imagine, continuing the story here, this creates a big problem when you have so many people and that much data trying to make sense of it. So in the work management space, we had three big problems to solve. One is if you're an executive, you really care about those top 40 stories that we talked about. If you are if you are in the team building the software, you care about the alignment across the big bets we're making together. The fundamental construct of this is what we call dependencies in the center of the slide here. This is all about the dependencies, right? What do teams need from each other to get their job done? That's the core thing right now with dependencies. So generally with dependency, we're talking about hundreds of these things, not thousands of them, these blocking items. So teams have to know what code they need from other teams to make their code work. And the last piece is this teams, if you're in small teams of 5 or 10, right? Great tools out of the box that come with Azure DevOps. But if you're a team of 500 plus and higher, it's more difficult to get a view of how this works, how it's all coming together, how are we doing, the health of that. So what the Windows 10 team did was they built these trackers. There's some extensions you can extend Azure DevOps. So they built these 3 trackers I'd like to just give you a quick preview of and show you what these look like. One is the story tracker. Again, these are the ones the Windows team built, and this view you're looking at is more for the executives on the Windows group. And when they're concerned about the 40 plus stories and how they're all coming together, they can use these tools. So they can drill into all the different promises that were made and make sure things are going well and what we really want to tell our customers. So they can scroll through these different stories. When they find the one they want, they can use this tool to actually drill in and get a detailed view of this deliverable, right? How's all the work coming together? So this is the big picture view per story. So let's look at the dependency tracker we talked about. So dependencies are interesting. Right? This is the work that one team needs to get from another to get their own work done. And of course, that work they're doing is dependent on some other team as well. So it just continues. So what you can get from this custom built extension is the health of the system and where the areas of risk are, right? It's a great high level view on how dependencies are coming together. Again, these are just to repeat that, these are about hundreds, not thousands of dependencies. The green is healthy, of course, and red is about the amount of risk. So on this chart's 22.5%. But this is a good view of, again, dependency trackers, very interactive and deep dives as well. When you drill in, you can view this by state, by team, by story. You can slice and dice this up however you like. But the things the teams are looking for is, is this item, is my item going to be cut? Is the team okay with cutting this item, or do we need that item? These are the types of things they look for, right? So they can drill into any one of these and basically evaluate what their risk is. Dependencies are also important because of time, right? They need to be sequenced correctly. So this particular view gives you a view of the dependencies across the calendar at a very high level. So when you drill into that, you can actually see if it's sequenced correctly and a status of the prior sequences. So basically it gives you a glance, at a glance it gives you this view of how the work is coming together across the timeline, across the top there. So basically the teams need the ability at scale, right, to see how the work is coming together in that. So the teams and the Windows team meets about once a month and they basically see how the work's coming together based on the dependencies. And they ask questions like, hey, did my work get moved out? Did my work get moved in? Hey, what's the state of my work, right? What are the teams that are expecting the new work? So this gives you at a glance view per month of the health of the teams as it works through its processes. So those three trackers I just talked about, that's just a quick view of how the Windows team does the work management piece of that. So what I'd like to do now is move on to basically Git version control. So as you can imagine, there's a lot more than just tracking work items, right? There's a lot of source code to track. I have some stats here to show you. It's hard to imagine what happens at this scale. So 7,000 developers making code changes. They have topic branches in Git, right? 11,000 plus topic branches in the commits. It's actually amazing the commits there. Pull requests and of course branch iterations. Just imagine the number of commits. It's 10 commits per minute. Pull requests at 33,000. It's about 1,100 pull requests per day. So reflecting back, the goal of 1ES is to adopt the same set of technologies throughout the company. So what we want to use is Git, right? Git is by far the dominant source control system in the industry today. But it's not just what we were using, right? We were using Source Depot from the Windows team. So remember back when we were talking about that. They were using Source Depot before Git came along. And so the 1ES team, what they did instead of directly moving to Git, they thought they'd go through, do a little diligence, right, before moving. And we evaluated Git against Source Depot. And they created a list of 20 different requirements. So you can see Source Depot on the left had a lot of red. And we see Git on the right of this chart, right? A lot of green. So the big red X is the top two, I'd say. The big red X is the top two concerned about supporting large scale and basically how to make a monolithic code base fit. So the good news is, since it met most of the requirements, since Git met most of the requirements to support Windows, we just need to figure out a way to make the pieces that didn't work. And then it would be good to go. So just a short, quick history lesson here. Git was written by a guy named Linus Torvalds. He built the Linux kernel as well, and what he did was build Git to help him build the Linux kernel. So if you look at the size of Git, 34 meg of Git is the code base for Git. Our Roslyn compiler, 230 megabytes, and of course Linux, 640 meg. Pretty big. You look at the source code size, right? So the Linux kernel is 640 meg. It's similar to a lot of repos we have at Microsoft. Look at the Azure Compute, 500 megabytes. So this is all about creating virtual machines, running virtual machines, and storage that goes with the Azure infrastructure as code or infrastructure support as well. But 500 megabytes. Now the VSTS, this is our Azure DevOps. I'm using the word VSTS because in the code base it's still actually called that. It's not so quick to rename things, but as we're talking about Azure DevOps today, it's about 3 gig for its code base. That's 6 times greater than a Linux code base. Then we look at Windows, 360 gig of code in Git. So just imagine if you were to run git clone, if you could clone the whole thing, it's about 86 git. 86 gigabytes. There's second line down. 86 gigabytes you'd be pulling down. So we decided to try this and throw Windows code base into Git repo and see what happens. So when the team ran the Git clone, they waited, and then they came back the next morning after still waiting until it finally finished. Then basically they ran a Git status and waited some more. Again, these are some of the numbers that you saw earlier. The goal of 1ES, empower our developers, make them more efficient. Right? Clearly, it's not that. This was an epic failure when they tested this out, right? As far as efficiencies go. So they tried a couple of different things and landed on this idea called, you might have heard of it, called the virtual file system for Git. The virtual file system for Git is basically it only downloads the part of the repo as you need it on demand. So we revisited the statuses here, and this is what allowed the Windows team to move into Git. So we went from 12 hours to 5 minutes, 3 hours, 30 seconds. We can do statuses now in 8 seconds on such a large code base. So it's pretty remarkable what happened here. And the way this works is like the OneDrive on demand. If you look inside the directory after you run a git clone, basically it looks like all the files are there, but they're really not. So when you open the file using, let's say, Visual Studio, you could open up Visual Studio Code, Notepad, VI. It really doesn't have to be anything special. Whenever you open it, it downloads the file and puts it on disk. So this was the key to Windows Team with such a large code base moving into where we'd be able to, being able to work with Git. And the secret on this basically is this thing called filter drivers right in the middle. This is very much like what your virus scanner does. It intercepts open calls, but instead of scanning for a virus, we basically go and download the file from Azure DevOps and put it on disk. So we've had pilot teams try this, and they were very successful. So based on their success, we realized, hey, bring in the rest of Windows into the team. So that's what started happening here. So you'll see by this graph, you look at the number of submits from the source depot, that's the blue, and the orange is the number of pull requests that were open. So notice the productivity did not decrease. In fact, after a couple of weeks, it went back up. So this was a huge success for the Windows team, right, working with Azure DevOps team. They built this functionality to Git, basically to work with large code bases. So now that we have all this source code, 640 gigabytes of source code in Git, how do you manage it? So let's look at that. That's the next section. Building. So how do we flow all that code from all those different developers, right? In the perfect world, we want developers working as close to master as possible. That is a best practice using Git. So working, let's look at a traffic analogy for this. If there were just a few developers, you want to merge your code together, it's pretty straightforward. However, it's much more challenging when you have about 7,000 plus developers trying to merge all their code basically on the same highway. It becomes quite difficult. I thought this was a cool analogy. So the way we handled this in the Windows team is to branch. So we branched to basically isolate development. Bottom layer on this slide. So this allows developers to be more efficient at their working level, right? They can integrate into their local integration branches which are just above where they're working. So one level higher. Then the idea is we have stewards, and basically they look over the larger branches to make sure that when all this code comes together, it comes together in a very thoughtful way, right? To allow all those code changes to flow to master, where we can do something with it and basically build it and have a set of tools. So we actually built, the Windows 10 team built an extra set of tools here, the extensions, of course, on Azure DevOps, to monitor the health of those branches. So each major branch has an owner who looks over the branch. And they ask themselves, hey, how's the branch doing? Are all the branches coming together from the sub-branches? Am I on track? Are the builds passing, etc., right? So once they feel that branch is in a healthy state, they can go ahead and pull it into master. So this view allows the teams to get on a calendar and view when others are planning their merges. So you see at the bottom there, it gives you a little bit of a calendar view and who's coming in. So teams can also see what others are, what they're getting with that merge. When they do a pull request or an integration, they can see exactly what they're going to get into their branch as well. So all of this is on a timeline, and to be planful and have merge that happens across the least amount of disruption is the idea. So calendar view helps quite a bit in that area. They can view the health of their branch on an ongoing basis for any particular build. They can see all the debt they're bringing in. Example. This shows how the health of the branch is going. Are other users using it? It's very important. So these tools I've showed you are very efficient for merging all of that code into master in a timely way. So it does have one very obvious challenge, right? As soon as you're doing isolation and layering, you're introducing the element of time. You have developers churning through quickly on their code, and they have created a challenge. They created changes, right? But there's no way to know, if you're a developer, right? There's no way to know if it will collide when they merge it until it hits one of the top integration branches, right? So this could be hours, could be days, weeks, just depends on the team's work. So this takes our developers out of their flow to have to, let's say, go back weeks and retrofit something that they fixed with whenever the time comes for the merge. So it just takes them out of their workflow. So how do we handle that? So what we want, we want to be in a world that's this pre-check and validation, which is down at the bottom there, PVC. The pre-check and validation. So this keeps developers working as close to master as possible. So the Windows team partnered with the Azure DevOps team, and they figured out a way to create this pre-check and validation. So let me just walk you through what this theory looks like. And again, there's something they're working on. But the theory is you have your working branch at the top, and you'll have a rolling build, right? So the rolling build will grab the source control. It'll go ahead and sync the changes, right? The last known build is prepared, and as developer at the bottom working off their own topic branches, now they're making their own code changes, but what they're doing is checking it against the pre-build, the rolling build. So they combine their changes with the rolling build. If the build's successful, of course, they're going to run tests. And because this is a slide, tests always pass, right? And if that is all successful, of course, they issue a pull request back to the working branch, back to master. So what this basically allows is the developers work closer to master, more locally, in a lot less time. In a lot less time. So we're seeing great results with this. This is the next step in the combination efforts of the Windows team and the Azure DevOps team to build this pre-validation tool that's coming. Let's look at testing and validation. Let's move on next. So the tests are all about caring about the quality, right? So this would be very difficult to do without automation. So they're testing for things like, does it work, right? What's the battery life? Does it boot? Does it perform the operations that they're supposed to? Is it useful? Does it do the things we set out to do with each of these devices? Do people even like it? These are the type of testing that happens, right? So we use an automated lab testing with the different quality gates, and these are critical. These are run all the time. You look at these 2,500 different desktops are tested, the different Xboxes there, virtual machines, HoloLens, almost 50 IoT devices. So this happens daily. So what I want to talk about is this thing called the Windows Insider program. So even with all the automation testing in the world, it's still inefficient to figure out if it's useful to people and if people like it. So this is why we started the Windows Insider program. And the Windows Insider program is across many different other products, right? The Insider program is, but the Windows Insider program has just recently started, right? It is the key for getting better and being more realistic, getting data on, does it work? Is it useful? Do people like it? So we actually look at the Windows Insider program to solve basically two primary challenges we faced in testing our work. Complexity. Complexity is one of those first things. So in the Windows ecosystem, there are 8.5 million unique devices and about 21 million unique applications. So when you combine that and do the math, it's a huge number of combinations of configurations that have to be tested against. So it's just crazy, right? Number two, latency. So generally speaking, Windows has a habit of working on products that take sometimes years, right? A couple of years, as you know. Right? Let's say 2 years. And there wasn't enough time in the 2 years between the betas, letting out releases of betas, pre-released betas, taking the feedback and fixing those to get them into the next release in time. There just wasn't enough time to digest all that feedback and put it into the next product. So as you can see by this graph, we went from, looking at the bottom, right? We went from 2 public previews to 3 public previews, all the way at the top, right? We actually are releasing the next, we're releasing the next release before the actual current release is even shipped. So we went all the way from one end of the spectrum all the way to the other. The Insiders program is worldwide. It covers 95% of all the hardware that we have out there, right? Found on the PC. So That's a really, again, it's critical to the success of building software at scale. We have this thing called quests. So the insiders get these quests, and the quests are all about the experiences we put into the insiders, right? We ask the people on the insiders to look at these quests. Is it useful? These are the types of things, right? Does it work? Do you like it? Does it work well if it works? Things like that. So over 1.6 million quests since a couple years ago, October. And because of the quests, right, because of the insiders, we almost have 500,000 bugs found. And they're all entered into the work management system and fixed. So this is where the whole system comes back together. We plan our work, we code our work, we use Git, we use build to build it, we use test to test it, we use automation for testing it, and then we put it out into the insiders and we get their feedback, and the whole cycle continues. So the insiders, again, critical part of the development cycle, as you can see by some of these numbers. Now this last graph here I wanted to show you is that this is the release, call this as the release quality view. So it shows all of the feedback is coming in from all the different categories across the different categories in Windows there, across the different experiences that we've set out to build, right? So this is the insider data that comes back. So this is where it all comes together full circle. Feedback, this feedback we get equates directly into tasks on a task board, and then it's assigned to developers, and again, the cycle starts all over again. So interesting view. We like to say sharing is caring. All right, this is a big part of the journey to DevOps is culture, right? We talked about people products, and culture is one of those. So the Windows team has taken all the extensions that they built. I've showed you those custom extensions, right? There was screens of custom extensions. They took all those extensions that they built, and they either added them into the Azure DevOps source already, or they put them basically into the open source projects so that anyone could take those extensions and run it in their own instance. So these are available. Some of the things I showed you today, you could actually go get these. So what this does is help unify, how all our teams talk to each other and work together. You'll see that this is great internally to Microsoft, but what about getting it out to the world, right? The next step. So we put 3 of the extensions you'll find, the work item, the extension for the Windows team. You'll see those out in GitHub, and I'll give you some links on where those are. The first one I want to talk about is this Windows, the item migrator. So the work item migrator, as you can imagine, has a lot of work items. We have, as you saw, millions of different work items. And sometimes you want to archive those work items. So you can see here, there's a link here to go get that extension, allow you to migrate and archive and mothball those work items if you want to. So those are out there. The next one is this work item one-click. As you could imagine, we talked about the 7,000 people on the team. The Windows team has customized the work item form pretty heavily. And what this extension allows you to do is preset a one-click action. So me, as a developer, can say, hey, when I pop this up and click this, I want to fill in my form with this type of data. And it's very customizable. So I thought that was a pretty cool extension as well. Just makes entering data a lot faster. The dependency tracker is what we talked about earlier as far as what code is needed across other teams. And this is a plug. Again, this is an extension you actually go install into your instance to allow you to look at the different dependencies across the different teams and what's coming down the pipe and so forth. So that is the end of how Microsoft is using Azure DevOps for building basically Windows. So I will. What I wanted to do. Let me see if I can pop up a window. Hang on there, Jason. I'll just pop this window up and give me just 1 second. Yeah, everybody, hang on tight. I'm going to show you. I'm going to show you something. If someone could let me know when they see this.
All right, I think it's popping up now.
Awesome. As a bonus, I wasn't sure if I'd have time, but I wanted to show you what basically we use Azure DevOps. The Azure DevOps team uses Azure DevOps to build Azure DevOps. And this is our actual live dashboards. So even this is the landing page for the Azure DevOps projects. You'll notice on the right-hand side, you can look at the repos here, the commits. Those are real-time. I can go over apologize if you're not familiar with Azure DevOps, but you'll see the menuing system. This is the new navigation system we built on the left-hand side. I'd recommend that. Very easy to get started with that as well. In fact, I'll show you a hidden gem. If you want to turn on some of the feature flags, you go up to the right-hand corner, click on your picture, click on Preview Features. This is where you can turn things on and off. And I turned on the new navigation system, which is right here. So we allow you to go look at the previews, which is pretty nice. But if I jump over to the dashboard, again, this is landing page for the teams to work. The idea is let's look at this one. Dashboards are great ways to set up widgets and customize the widgets to see how things are building, how things are progressing, how the test's running, are there any failures, how's the pull requests, etc. I see my screen resolution is really high, so let me just reduce that just a little bit. So for instance, I'm looking at some real running builds here. You can see on the master branches, we have builds running. We have many different rings of deployments. All the blue, of course, these are all active live right now. I can scroll down a little more. So I can see that my production pull requests here at the bottom, my production updates at the bottom here, across all these, every column is a different, basically a different area that we deploy to. We call it rings. On the dashboard, each one of these are deep dive, deep links. So let me jump into one of these. We'll just have a little fun and off-road this. So looking at this last build, I can just click on one of these builds. It will take me to our build pipelines. This is the Azure pipelines, and actually show me something running. Again, the builds are running some progress right now. We can see the actual steps on which agent it's running, etc. If I were curious about, well, how are we doing deployments, Randy, I can jump over to the pipeline releases and actually look at something that's in progress now. I'm sure we'll catch something running. So I can look at all the different releases that are going on. These are actual, again, live releases. So let's just look at this. Let's look at this one right here. This was just released not too long ago. Again, production update. If I click on this, it should pop in and show me that. Internet might be just running a little slow today, but we'll just see what happens here. So this is what one of our release pipelines look like. And if you haven't looked at build pipelines, I suggest to just go play with it, look at it. But you can get pretty complex with your release cycles. But generally, the concept is releasing to dev environments and QA or staging, blue-green environments, and then production. I set tasks. You can see what's going on in each one of these. So it's great for monitoring exactly what's going on here. And then we pin these to the dashboard so we can see what's going on. So this is a quick release on that. I just wanted to show you we're doing okay on time. So I want to take you on a little bit of a tour here. Let's look at our code base as well. Remember when I was talking about developers staying as close to master as possible? You can see the graph on the left-hand side. Again, we have topic branches. We stay within one or two off that. So that's a good best practices. We also put policies around our master branches, so we make sure everything's working well there. But this gives you an idea of real time, what's actually going on here. The other piece I'll show you is this idea of pull requests. So I can go in and actually look at a live pull request, like this one. Here's one that's 5 hours ago. Let's go look at this one. So with a pull request, I can very easily go in and see who the reviewers were, who approved this. I can look at the files that were actually being merged, so we can scroll up and down here and see what actually the delta between what's asked to be merged and what the pull request was. Was it resolved? What build it was in, etc. So that's the idea here. But you can see what's going to be merged into master. Are there any commits and so forth? One thing I want to show you on builds again, it's nice to look at a specific build. So here's the Visual Studio Online build. And I can actually go in and look at the analytics for, you can just pick any build you have and say, hey, over time, how are my builds going? Let's look at this. We provide these Power BI analytics built into the widgets here to give me my overall test. Basically, hey, are the tests passing or not? I can change some of the values at the top here over 30 days and see what's looking like. So again, each one of these you can drill in and say which test is failing, why it's failing. And of course, the other piece of DevOps, I didn't start there, but the other piece of DevOps on the left-hand side is I can jump into the agile boards. So let's go look at a real live board and see what's going on here. Again, teams have the autonomy to give themselves different names. There's a lot of different names here, but as you see, this is a real live board, customized. Anybody can customize the columns that you see here. You can change the column headings. I can look at a feature timeline, so what's coming, right? I can go to the upper right corner. I get my burn down. I get my cumulative flow, cumulative burn downs, etc. here as well. Let's look at the feature timeline, see what's going on there. So what's nice with this view, this is just a different view of the data. I can look across sprints to see what's coming, what current sprint we're in. We see we're in sprint 143 here in the center, and then what's coming down the road. So good there. The other thing I can do is go back to the board. Again, this is the Kanban touch board, a lot of different customizations I can do on this board, change colors. I can use filtering and shading and things like that. But if I want to just view this as a backlog, this is where I can actually look at it more, I'll say Excel style, but you can export data in and out of Excel. But here I can actually take these items. I can see on the right-hand side the sprints, the number of items that are in each of these sprints, what's planned, and so forth. You can see our sprints are planned out through February. And of course, this provides the drag and drop into the sprints and however the teams are using this. So I'm looking at the WIT Z team at the moment. There are many different teams inside here. The other thing I'd like to show you is if I go into an actual sprint, let's just click on this current sprint, sprint 143. So once you get out of the backlog, I can jump into the actual sprint. The sprint provides a board as well, and I can even toggle this from, you'll see I can come over into the right and toggle this from the planned work to the actual work details if I want to look at it this way. So you have a choice on that. I could also go into the actual task board. Again, there's just different ways to look at the same data. So these are the task board. I could collapse all these and get this nice rolled up view of what's going on in any one of these. So if I were to come down to here, I can actually see across these different columns what's going on. Another thing I'd like to show you is the ability to, we talked about the dependency tracker. Let's see if they have any dependencies on this one. So the dependency tracker, I talked about that throughout the, I guess there aren't any on this particular graph. Well, you'll have a screenshot in this presentation. This is that dependency graph I talked about. It looks like a spoken hub. That's what this would be. I'd have to find the right team here. Again, I'd have to look around for this. What's also interesting is the idea of planned work. So if you're managing teams across multiple projects, there's this area called the plan tracker that I can actually go in and add multiple teams to. And then the idea is I can compare team A, team B, team C with their sprints across time, across this calendar, so I get a nice all-up view of what's going on with the different teams across these different areas. So that's really what I wanted to show you. I'll go back to the dashboard, see if that updated yet. As you can imagine, there's different dashboards I can pick here. If you're not familiar with this concept, I can create custom dashboards. I can create custom widgets. I can move the widgets around. If there's something that's not here, I can go to the marketplace, install the widget, and do fun things like that. All right. So I will go back to the home page here, and I'll hand this back over to Jason.
So, Randy, that's fantastic. This is fantastic where we were able to get your knowledge and kind of let everybody see, what a little bit inside Microsoft. So thank you so much for presenting this information. Guys, as we do this monthly, we try and take topics that are very current in today's market, and DevOps, from an Azure DevOps standpoint, this is absolutely something everybody's interested in. So I appreciate everybody joining us. We continue with these monthly webinars. We'll be sending out a follow-up on this, and make sure if there's any questions, please reach out to us. If there's anything that anybody needs, please contact us, and we will surely follow up with you. Thank you so much for attending, and we look forward to seeing you next month. Thanks, Randy.
Thank you, everyone.